Safran's new open-fan aircraft engine moves closer to real flight testing by 2029. Backed by €100 million from the EU's Clean Aviation program, the Safran-led project is preparing an open-fan demonstrator for flight tests by 2029. Franco-American aerospace company CFM, a joint venture between Safran Aircraft Engines and GE Aerospace, has moved to the next phase of development for its open-fan engine technology. The venture officially unveiled the European Union-funded Takeoff project last month. The project is coordinated by Safran and backed by €100 million, $116.9 million, from the Clean Aviation program. It brings together more than 24 partners, including GKN Aerospace and Airbus. The project's objective is to prepare an open-fan engine demonstrator for flight testing by the end of the decade. Open-fan engines have the potential to increase fuel efficiency and reduce emissions by as much as 20%. Pushing beyond the limits of today's ducted fans, Takeoff stands for Technology and Knowledge for European Open-Fan Flight. It forms part of the broader CFM RISE program. The program is a joint effort launched by Safran and GE Aerospace in 2021. Open-fan, or open-rotor, architecture removes the traditional nacelle around the fan. This allows for a much higher bypass ratio. The bypass ratio refers to the amount of air that bypasses the combustion core compared to the air that passes through it. In simple terms, an engine with a higher bypass ratio moves a lot of air slowly, whereas a low bypass ratio engine moves a small amount of air very fast. The engine with the higher bypass ratio can produce the same amount of thrust using less fuel. This is why modern airliner engines are high bypass, they are quieter and, crucially, more fuel efficient. Traditional ducted engines are reaching the limit of efficiency gains in this area, with bypass ratios of 10:1 to 12:1. 10:1 means 10 times more air passes through the fan duct than the core. With its open-fan or unducted engine design, the Takeoff project is aiming for a 60:1 bypass ratio. Ultimately, as CFM noted back in 2021, this could lead to approximately a 20% reduction in fuel consumption and emissions. Open-fan Airbus A380 flight tests scheduled for 2029 CFM's RISE program has made important strides in recent years. Since 2023, it has developed individual components, including the unducted fan, high-speed booster, compact gearbox, and lightweight structures. In tests, these have already exceeded the 20% fuel burn reduction target. The program has also completed more than 400 hours of wind tunnel testing. These tests provided data on performance, acoustics, and aircraft installation effects. Now, with the Takeoff project, it is shifting its focus to system-level verification, including icing tests on fan blades, high-speed wind tunnel acoustic evaluations, and durability assessments. Key upcoming milestones include full-scale ground testing of the front module at a new Safran facility in early 2027, followed by integrated ground tests in 2028. If all goes to plan, Safran would then perform a flight test campaign in 2029 using a complete engine prototype installed on an Airbus A380 flying testbed. Data from those flights, covering taxi, takeoff, cruise, descent, and landing, will inform final design and certification efforts. Ultimately, the goal is to start commercial operations with open-fan engine airliners by around 2035. Challenges remain. Open-fan engine designs promise major efficiency gains. However, they also present serious challenges that could limit widespread adoption. Though a higher bypass ratio typically means less noise, open-fan engines are usually noisier than ducted turbofan engines. This is due to the fact that there is no nacelle to contain and attenuate sound. Still, Safran officials say recent advances in simulations and testing have shown great promise for enabling quieter blade designs. When you try, you always learn, so we will learn on the aeromechanical aspects, on altitudes, on the system, for example, said Delphine Dijude, Deputy Vice President for Engineering, Research and Testing at Safran Aircraft Engines, as per a report from Aerospace America. We will learn how to demonstrate that we are flight-worthy, and it will also feed all the design requirements for the mature product. Pierre Durel, project officer at Clean Aviation, meanwhile described the effort as a high-risk, high-reward kind of project, highlighting its unique potential for enabling important propulsion efficiency gains